distribution has many applications in statistics. We begin with a definition of the distribution itself. In later sections, we will see some of these applications. The chi-square distribution is the distribution of the sum of squared standard normal deviates. The degrees of freedom of the distribution is equal to the number of these squared deviates. Therefore, chi-square with 1 degree of freedom is simply the distribution of a single normal deviate squared. Chi-square is written as the Greek letter chi squared, with the degrees of freedom in parentheses. Let's consider a simple problem. Although this problem does not have obvious applicability, it will help clarify what the chi-square distribution is. Say you sampled 2 scores from a standard normal distribution. Let's call them R1 and R2. You square the 2 scores and add the squares together. What is the probability that the sum will be 6 or higher? There's nothing special about the number 6, it's just used here as an example. Since 2 squared standard normal deviates are summed, the distribution is a chi-square distribution with 2 degrees of freedom. We can use the chi-square calculator to determine the probability of getting a chi-square of 6 or greater simply by filling in the text boxes and clicking the OK button. The answer is that the probability is 0.0498. It should not be surprising that the probability is low, since the distribution has a mean of 2, its degrees of freedom, and therefore a value of 6 or more is unlikely. One important attribute of the chi-square distribution is that its mean is equal to its degrees of freedom. A second important attribute is that the chi-square distribution approaches a normal distribution as the degrees of freedom increase. That is, the more degrees of freedom, the closer the chi-square distribution is to a normal distribution. Here is a chi-square distribution with 2 degrees of freedom. It has a very large positive skew. With 4 degrees of freedom, the skew is reduced. With 6 degrees of freedom, it is beginning to look a bit like a normal distribution. The chi-square distribution has many applications. In this chapter, we will see how it is used to test differences between observed and expected frequencies. We will also see how it's used to test the relationship between categorical variables. There are numerous other statistical tests based on the chi-square distribution that will not be covered here.